Welcome to qnawire.
Hi, so for this question, in the first case, we have a strong acid with a strong base. So in that case, we don't need to do any calculations in order to get the pH at the equivalence point because we know that at the equivalence point, we have added in our ice table the same amounts plus NaCl in this case. Of water, we start with 0, 0, over here, 0 plus C0. And at the equivalence, we have 0 of the acid, 0 of the base, and of water, we know that the pH is going to be neutral. And finally, we know that we have a C0 concentration of salt. So in the first case, the pH at the equivalence point is that of water, so pH needs to be equal to 7. So now, for cases B and C, first of all, I'm going to derive the equation for a general weak acid that is being titrated with a base. So we know that a weak acid, we can write it down as HA, that in presence of a strong base, OH minus, is going to generate its conjugate base, A minus, plus water. So at the equivalence point, where we can write down our ice table in terms of concentrations, we have a C0 value of HA. At the equivalence, we have added the same amount of OH minus, and we're going to generate a portion of A minus. So minus C0 plus C0, and water, it doesn't matter, right? Because it doesn't enter into our equilibrium equations. We have 0, 0, and A minus. We end up with C0. But now what happens? Well, A minus can react then with water in order to produce HA plus OH minus again, right? So at equilibrium in the equivalence point, we have an initial amount of A minus of the conjugate base that in the presence of water is going to generate more HA plus OH minus. This according to the KB for this result. Okay, so again, we can go ahead with our ice table, C0, 0, and 0. The amount of change, we're going to call it minus X. We're going to produce plus X and plus X over here. So at equilibrium, we end up with C0 minus X, X, and X. Now, what this reaction corresponds to? This reaction corresponds to Kb. And remember that Kb can be related to Ka and Kw. There are two different ways to look it up. First of all, pKa plus pKb is equal to pKw, that is equal to 14. Or the other way to look at it is Ka times Kb needs to be equal to Kw, which is 10 to the minus 14. Now, with this taken into account, the value for Kb is equal to the concentration of HA divided by OH minus divided by the concentration of A minus. Replacing the values that we have, this becomes x squared, because we have x of HA, x of OH minus, divided by the concentration at equilibrium, C0 minus x. So now, in general, when we have weak acids, the value for x is going to be much smaller than C0. So we can approximate C0 minus x as approximately C0. So the concentration of OH minus, or the value of x, can be found directly using Kb. So Kb is equal to x squared divided by C0. Thus, the value for x is equal to the square root of Kb times C0. And what this x represents? Well, this represents the concentration of OH minus, as you can see from the ice table above in here. Excellent. So if we know the concentration of OH minus, we know the POH. And if we know the POH, we can get the pH as 14 minus POH. So now let's do the calculations for case B and C. For B, we know that the Ka of the asset is 1.3 times 10 to the minus 5. This means that Kb is going to be equal to 10 to the minus 14 divided by my Ka coming from this equation, which is 1.3 times 10 to the minus 5, giving us 7.69 times 10 to the minus 10. The initial concentration in this case, and actually in both of the cases, it's going to be the same, and it's going to be 0.079. Thus, the value for X, which is the concentration of OH minus, becomes square root of Kb times C0 equal to 7.8 times 10 to the minus 6. The POH is minus the logarithm of concentration of OH minus, which is 5.1, actually 5.11 if you want to round it up to two significant figures. Thus, the value for pH, which is 14 minus POH, at the equivalence point will be 8.89. Now we can do the same procedure for part C, where the only thing that changes is the value for Ka. So in this case, Ka is equal to 2.5 times 10 to the minus 9. Thus, Kb is 10 to the minus 14 over 2.5 times 10 to the minus 9. Which gives us 4 times 10 to the minus 6. We know that X is Kb times my initial concentration, which I mentioned that was 0.079, as well in here, giving us a result of 5.62 times 10 to the minus 4. And this is the concentration of OH minus. So the POH is 3.25, and the pH would be 10.75. And this would be the final answers. This would be for B, and this would be for C. With that, that would be all. Thank you very much.